Hello class, let us have a look at some of the pictures here. What are they trying to do here? What is the common thing they are using? Can you say? Yes, they all are applying force to do some form of work. At the end of the lesson, you will be able to define force, identify the direction of net force applied in a given situation, identify the effect of force on objects, identify different types of force applied in the given situation. Now, let us have a closer look at the picture shown earlier. There were 4 pictures here. In the first picture, we see the person is trying to fetch water from a well. Look closely how he is able to achieve that. In the second picture, the person is moving a block of something which is quite heavy, I guess. So how he is able to achieve that again? In the third picture, we see this person dragging a wooden log with the help of a rope here. In the fourth one, we see this person kicking a ball. In all of the pictures, we can see that they are applying force. So we cannot say he is kicking the ball, or he is opening something, or he is opening a door, or something like that. So in general, we can see that force is an action of push or a pull. So in the first picture, we see that he is pulling the rope. In the second one, we see that he is pushing the block. And in the third one, we see that he is pulling the wooden block. And in the fourth one, the person is kicking or pushing the ball. All of them are interacting to apply force, meaning they are touching the object. So we can say that force is the action of push or a pull. Force is denoted by letter F. The SI unit of force is Newton, which is represented by capital N, and force can be applied by the interaction of 2 objects. Let us have a look at what force can do. Let us look at closely some of the illustrations given. So we are discussing the effects of force. Look at this car here. This car is in position A in the beginning. When force was applied, that is, the person pressed on the accelerator, it accelerated and reached to position B. When it started from A, it was in motion in between and came to a stop or rest after force or brakes were applied. Thus we can see that force can change the state of an object. That is, it can cause resting body move or moving body come to a rest. Let us look at the second illustration here. The first car we see has a very high speed because it's moving very fast as compared to the second car. The second car is quite slower, isn't it? We see that when force was applied on the first car, that is, it was accelerated, it moved faster. In the second one, when brakes were applied or the force was applied, it started moving slower. So we can say that force can increase or decrease the speed of an object. In the third illustration, we see two stick people or two boys are playing football. The first one kicks the ball and passes it to the other one, and then the second one kicks it again and passes it to the first one. What we see here is the ball is going in a different direction. So we can say that force can change the direction of an object when applied. Lastly, we can see a simple illustration shows that the paper, which is rectangular in shape, gets crumpled or changes into a ball-like structure or in any irregular structure when force was applied. So this can prove that force can change the shape of objects. Thus, from the above illustrations, we can see that force can change the state of object. That is, if an object is at rest, it can make it to move when we apply it, and if an object is moving, when we apply force, it can come to a rest or to a halt. Second, it can change the speed of objects. That is, it can increase or decrease the speed of objects when force is applied. Force can also change the direction of the object, and it can also change the shape of an object. Let us now have a look at some illustrations here. This person is trying to push a heavy table alone, but it is quite heavy, so he is not able to move it. So what he does is he calls his friend standing there, and then his friend comes and helps. So we see that when the friend also helps, they are easily able to move the table, and they are applying force in the same direction. So we can say that the net or the total force, when they are applying in the same direction, gets added, and they are able to move the table very easily. In the second illustration here, two boys are trying to push each other who are both equally strong to one another. So they are unable to push either of them, as they are applying the force in opposite direction and in equal magnitude or strength. So here the net resultant force or the total force becomes 0. So they are not able to move from their positions. So we can say that if one of them is stronger than the other, then they can move. The stronger one will move, the weaker one, and can win. But if they are of equal strength, they will not be able to move, and hence we say that the resultant force is 0. Let us now have a look at the different types of forces acting in different situations. We have two types of forces. One is a contact force and the other one is non-contact force. In a contact force, we have muscular force, mechanical force, and frictional force. And in the non-contact force, we have gravitational force, magnetic force, and electrostatic force. Contact forces are those which are exerted on any object when they are in physical contact or they are touching each other. A non-contact force is exerted on any object without any physical contact on the object. Now let us discuss what are muscular forces, which are also known as contact forces. We see here in the illustration, the stick man is trying to pull up. So he is doing his exercise and he is using his muscle to pull himself up the bar and go down and come up likewise. In the second one, we see that a person is trying to show his muscles or biceps by folding his arms. So those are the muscles that we use to work, or we use muscular force. And we, not just we, but the animals also use muscular force to do different kinds of work like walking, jumping, running, etc. Mechanical force are those forces which are done by machines like the grinder, mixers, fans, bicycles, engines of cars, etc. Here we see a windmill is rotating with the help of wind and it is churning something inside, so we call that a mechanical force. In this illustration, we see that a hammer is hitting a nail and the nail is going inside, so we call also this a mechanical force. At the same time, the nail is able to hold it, or the nail is able to go inside. It is not coming out after hitting it, so because of the frictional force. In the second one, we see a person rolling a circular object and the other one rolling a cuboidal object. We see clearly that the person rolling the circular object is able to move it easily, whereas the person moving the cuboidal block is unable to move it easily. We say that the friction is more in case of the second one than the first one, so that the first one is able to move it very, very easily. So we call such force which opposes the motion as the frictional force. Now let us quickly have a look at the non-contact forces. The first one, that is the gravitational force. There's a saying that what goes up must come down. So we see that the stick man is throwing a ball in the air, and we are not amazed by it because the ball after some time drops on the ground. So we say that the gravity of the earth is pulling it. This gravity is helping us to stay on the earth. This gravity is also helping us, our planet, to stay in its orbit in the solar system. So every object has gravitational force. So we also, in our earth also, we have gravitational force. So this is one type of a non-contact force. In the second illustration, we can see a person trying to blow up a balloon, and when he does that, he rubs it against his hair, and there are some bits of paper on the table which are black in color, and then when he rubs the balloon on his hair and brings it near the bits of paper, the bits of paper gets attached to the balloon, and this is due to the electrostatic force or the electric force that is present due to the rubbing of the balloon on the hair. The last illustration gives an idea of another non-contact force, that is the magnetic force. You all are very familiar with the magnets. You all have touched it or played with it once in a while in your life, and then you have tried to attract different kinds of metals and pins and all kinds of things. Here also we see when a magnet is brought near iron nails, the iron nails get attracted and then gets attached with the magnet. So we see that the magnetic force is attracting the nails, and then they are able to get attached with the magnet here. So we call this magnetic force. So these are the types of contact and non-contact forces. So this ends the first part of the chapter, that is force. We have learned so many things, so we can write them down, we can revise them, and then you can try to answer different types of questions relating to your usual daily